A building management system, or BMS, is exactly what it sounds like, a way of controlling and coordinating a building so that it will function properly. This often means making sure that it works around humans and equipment. So, for example, making sure that lights come on when they're required, spaces are at the right temperature at the right time, the air remains fresh, and that some areas remain out of bounds. A building is much like a human body. It breathes, it pumps fluids, it moves, and all of this requires the signals sent along conductors from a control centre, much like the nervous system and the brain. So, like a living thing, it needs sensors, signals, controls, and both automated and manual systems. So, just like a human body, a building management system is no single part in isolation, but requires all the components working together to make the system. A BMS is typically split into three parts or levels. These are the field level, the system or automation level, and the management or executive level. These can be thought of as hardware, software, and the user interface levels as well, although each layer will include some elements of each. The first level is called the field because it's the equipment which is out in the field. In other words, it's the stuff that you may well be able to see throughout the building in everyday life. It has three jobs to do. First of all, it collects data about the various physical aspects of the building. This might be things like the level of light, the temperature or humidity of a space, or even if there's people within a room, referred to as occupancy. But it may also include things that we can't detect with our senses. So perhaps the flow rate of water or another fluid in a pipe, the pressure of a gas within a tank, or the amount of carbon monoxide in the air. It can also monitor the amount of services used by metering electricity, water and gas. The second role of the field level equipment is to execute control commands as they come in from the automation layer. So a water pipe might have a valve that needs opening, closing or adjusting to control the flow. Or a baffle in a ventilation duct might need opening to extract more air by means of an actuator. The final job of the equipment at this level is to communicate information back to the automation layer. This might be in the form of data that's been collected over a period of time, or status updates about the device itself, or, very often, real-time feedback on how a system is performing at any given moment. This information is sent up to the second level of the system, the automation or system level. This is really the heart of the system, where all the data, processes and instructions are consolidated and carried out. The equipment used to do all this is housed in control panels like this one, and this is where the sponsors of this episode come in. Among many different services, Crompton Controls build panels for BMS systems, from small panels for simple installations, right up to large units for more complex projects, all put together using the latest technology by skilled operatives right here in Wakefield. But what's going on inside these panels? Inside the panel and at the heart of the system, you'll find this, the Direct Digital Controller, or DDC. These devices receive all the information from the sensors and monitoring devices in the field layer. They then process the data by comparing the values they get against set thresholds and parameters that they're controlling and see if the current conditions in the building are meeting the preset requirements. They will then make a decision about whether something needs to change. Maybe the temperature of a space needs raising or lowering, the flow rate of a liquid in a pipe needs to increase, or an extractor fan needs to run at a higher speed to freshen the air up. Once this decision is made, the DDC carries out another of its duties by sending a signal to the field level to carry out an action, firing up a boiler or opening a valve and so on. The final duty of the DDC in the automation level is to send and receive information to and from the third level of the system, the management or executive layer. This is so called because it's the place where commands are executed or carried out. The parameters and settings on the DDCs can be controlled and adjusted in a couple of ways. The first is by plugging a dedicated operator terminal into the DDC and programming it from there. Modern DDCs will connect to a variety of devices via either a hardwired network cable or a wireless Wi-Fi connection with apps and software that will allow you to connect, control and modify the program that controls the building, as well as overriding the system if necessary. So the management layer is the part of the system where humans and machines really come together. Using a standard computer or perhaps a dedicated human-machine interface device, or HMI, this is where all the information gathered from the building sensors and controllers is brought to life on screen. Think of it as the dashboard of the building, where everything that's happening inside can be seen, adjusted and analysed. At this level, you're no longer dealing directly with valves, sensors or control panels, but with visual representations of what's going on. Graphs, gauges, alarms and live readouts that make the whole system understandable at a glance. Sometimes these might be representative images of the physical devices to help you understand what you're looking at. The management layer has a few key roles to play. First, it handles data interaction. That means showing real-time information about how the building is performing. Things like temperatures, pressures, lighting levels, and any system alarms that might pop up. Through the HMI or supervisory software, operators can see what's happening right now and make adjustments if needed, perhaps changing a temperature set point, tweaking a schedule, or altering how long certain systems run for. If something goes wrong, the management level will raise an alarm, alerting the operator straight away so that they can take action before a small issue turns into a big problem. Next comes control. The management level can send high-level commands down to the automation layer, effectively telling it what the new targets or set points should be. It also provides manual override options, allowing engineers or operators to take direct control when carrying out maintenance or responding to unusual events. Finally, there's data analysis and reporting. The management layer doesn't just show what's happening right now, it also looks back at what's happened over time. By collecting and storing historical data, it allows for trend analysis, helping to identify patterns, predict maintenance needs, and fine-tune performance for greater efficiency. From this, it can also generate reports showing energy use, system health, and overall performance. Valuable information for both operational teams and building owners alike. So, in simple terms, the management level is where humans meet the system, decisions are made, and insights are gained to keep everything running smoothly, efficiently, and intelligently. So that's an overview of a BMS system. This video is the first in a series on BMS that forms part of a training package to help you with your CPD. If you're watching on our training platform, then answer the multiple choice questions that follow and move on to the next video. If you're watching on one of our social media channels, then click the link to move over to the free training package and get yourself a certificate. Or you can watch the same video in the series either right here or at the link in the description to find out what the different components of a BMS control panel are. All that remains in this video is to say thank you very much for watching.